Okay, and so we are going to continue getting tricky with it. And today we are going to look again at the ratios, but this time at where they come from, or more specifically, where the values for certain angles come from. Okay, so here we go. So having a look in our log tables, we would come across this particular table here. Okay, and as we can see, for all of the kind of special angles, so 0, 90 degrees, 180, 270, 30 degrees, 45 and 60 degrees, we have these values for sine, cos and tan. Okay, and so if we have a look, what we're going to do now is have a look at how these are formed for these three special angles. Okay, and see can we construct them. The easiest thing for us to do is, well, if I have in a right angle triangle, if I have a triangle with 30 degrees, then the other angle has to be 60 degrees. Okay, so the first thing that I'm going to do is to construct a triangle with 60 degrees in it. Okay, so the triangle that I can think of, the first one that I know that produces an angle of 60 degrees is an equilateral triangle. So we are going to construct an equilateral triangle and use that to form our sine, cos and tan ratios for 60 degrees and for 35 degrees. Okay, so here's my equilateral triangle. Now to give me a right angle in it, I am going to draw a line from this vertex straight down here. So that would bisect this line here, okay? Okay, so I'm just going to put in measurements into this. So if I decide that this side here is a unit of one unit in distance, then this side here also has to be 1 unit. So if it's an equilateral triangle and these have been 1 unit, this side here and this side here, so that gives a total of 2 units, then that also means that this side here is 2 units, okay? And again, just noting in our right angle there. I'm going to label the sides here. So, well, this is our hypotenuse anyway, which is opposite. I also know that this side, that down here, we have 60 degrees. Okay, so this angle up here at the top, where I've bisected it with my vertical line, this must be 30 degrees. And just to complete our right angle triangle, I need to get this length here. Okay, so here I have a right angle triangle. I have two sides. So to get the other one, I'm going to use Pythagoras' theorem. So here, so using Pythagoras' theorem, well, I know x squared plus 1 squared is equal to 2 squared. So that gives me x squared plus 1 is equal to 4. So x squared, to get x squared on its own, I'm going to take away 1 here. So I take away 1 here. They cancel, and 4 minus 1 is equal to 3. So x is equal to the square root of 3. Okay, so I'm going to fill that in here. Square root of 3. Okay, so that's the first bit done. Okay, and the first set of angles that I'm going to concentrate on is the 30 degree. So I'm just going to draw out this right angle triangle here again for myself. And again, just a rough sketch. Okay, so I have 30 degrees here. I have my right angle here. I know that this side is 2. I know that this is 1. And I know that this side here is root 3. Okay, labeling the sides of my triangle. Well, I know here opposite the hypotenuse, or opposite the right angle is the hypotenuse. Opposite the angle itself is the opposite. And then the final angle is the adjacent. And then writing out my mnemonic, oh hell, another hour of algebra, I know that sine, cos and tan are equal to the following. Okay, so I will start with sine then. So sine of 30 degrees is equal to, well, opposite over hypotenuse. So the opposite is 1 and the hypotenuse is 2. And I know I'm correct there because I can see it up here in my table right here. Okay, I'll have a look now at cos, and I know, so cos of 30 degrees, and that's going to be the adjacent. Well, the adjacent in this case is root 3, so it's root 3, and that's over the hypotenuse, which is root 3 over 2. Okay, and then back to tan. Well, I know that tan is equal to, okay, so drawing out our right angle triangle again, and this time we're concentrating on 60 degrees. So here I'm going to put in my 60 degrees here. And again, I'm going to label the sides of my triangle. So opposite the right angle, I have H. Opposite the angle this time is over here. And then my adjacent lastly goes in. And so again, I'm just going to write out sine, cos, and tan of 60 degrees. So sine of 60 degrees is equal to opposite. So opposite 60 degrees is root 3. And that's over the hypotenuse, which is over 2. Okay, the next one then, cos of 60 degrees. Well, that's equal to the adjacent, which in this case is 1, over the hypotenuse, which is a half. And then lastly, tan of 60 degrees is equal to the opposite, which is root 3, over the adjacent, which is 1, which is just the same as root 3. Okay, so that's our trig ratios for 60 degree angles completed. We've already done our 30 degree, so now we're going to have a look at our 45 degree angles. Okay, and so in order to construct a triangle with 45 degrees, I'm going to draw a unit circle. Okay, so this is what a unit circle looks like. And so to make a triangle out of that, I'm going to draw a line from this point here down to this point here, a diagonal line. Okay, so here this distance is 1 and this distance is also 1. And so using Pythagoras' theorem to find this distance, and just also before I do that, marking in, here's my right angle. And these two, basically I have an isosceles triangle with this. So which means this angle has to be equal to that angle. And 90 degrees divided by 2 means that they are both equal to 45 degrees. And so I'm just going to write that in here. So this is 45 degrees here, or this one here is 45 degrees. Okay, so we'll just use Pythagoras' theorem to solve for x. And so x is the hypotenuse in this case. And so I know that x squared is equal to 1 squared plus 1 squared. So x squared is equal to 1 plus 1. X squared is equal to 2. So x is equal to the square root of 2. Okay, so I can write that into my triangle here, my unit circle. Okay, and just sketching that triangle out for myself again. So here I have the triangle. I know that this is 1, this is 1, this is root 2. Here's my right angle, and I'll take this bottom angle here to be 45 degrees. It doesn't matter which one I use really. And as normal, I am going to label the sides of the triangle. So opposite my right angle, I have H. Opposite my angle, I have O. And then lastly, I have my adjacent. Okay, and so here we have our mnemonic for sine, cos, and tan. So O had another hour of algebra. And so just writing out here, I'm going to say, well, sine of 45 degrees and that's equal to the opposite, which is 1, over the hypotenuse, which is root 2. Having a look then at our cos of 45 degrees, that's our adjacent. Our adjacent in this case is also 1, and that's over the hypotenuse, which is root 2. So they're the same for a 45 degree angle. And then lastly then we have tan of 45 degrees. So here I have tan of 45 degrees, and that's equal to the opposite, which is 1, over the adjacent, which is 1, which is equal to 1. And so again, that completes for our special angles, the ones that we're concerned about. Okay, so make sure you have all these notes completed in your copy.